Let's look at another example. In 2008 in the United States, there was a major presidential election between Barack Obama and John McCain. They were both senators in the United States Congress, and they're both running for president of the United States. And it was a historically important election of interest to political scientists, but also to historians who want to look at historical patterns of electoral processes. In 2008, we had these election results. The United States has a process of electing presidents based on what we call the Electoral College. The basic idea is rather than counting the votes of everybody across the entire country in the United States, what they do is they, based on the percentage within each state, right, each state is awarded a certain number of Electoral College votes, and the idea is that the person who is elected president has the most number of Electoral College votes, where in most states, if you get a simple majority in a particular U.S. state, you get all those Electoral College votes. In the United States, intuitively you can kind of think of it this way. The idea behind it, even though it's been highly criticized as being, to a certain extent, anti-democratic, the idea behind it is that if you treat each of the U.S. states as different countries, right, you kind of aggregate based on the population of these different states, how each state votes in terms of whether it's for a certain presidential candidate versus another one. The other thing you'll notice about the U.S. context is that there are only two major political parties, and so there are really only two major viable political candidates. This is unlike other countries in Europe or elsewhere. Another point you should keep in mind for those of the students who are not from the United States is that in the United States, we actually reverse the colors. So the two major political parties are the Democratic Party and the Republican Party in the United States. The Democratic Party has historically been considered a center-left party, whereas the Republican Party has historically been considered a center-right or conservative party. On this map, the Conservative Party is labeled red, and the center-left party is labeled blue. That's actually the complete opposite of elsewhere in the world. Elsewhere in the world, red is the party of the left, and blue is the party of more conservative parties. So just when you look at this map, keep that in mind. You can see here that the electoral process, it's based on Barack Obama and John McCain winning certain states. Right? Obama won the states in blue, and John McCain won the states in red based on the percentage of people who voted across these different states. Now, let's imagine you go back in time. Right? So the U.S. presidential election between Barack Obama and John McCain was in November of 2008. But let's go back to October of 2008. And suppose you were a political analyst in October 2008 and you wanted to predict the future. You wanted to predict who was going to win, Obama or McCain, in November of 2008. And suppose you've had an assistant collect data on the characteristics of U.S. states. Could you predict who would win the 2008 presidential election using a multiple linear regression model? So this is a data set. Right? We have 50 states in the United States. Right? Alabama, Alaska, all the way down to Wyoming. It's listed alphabetically. And then we have various characteristics. Here we've shown the region, the population of the state, the percent who graduated from high school in these different states. High school is roughly 12 years of education. Suppose, based on previous analysis, you think the following characteristics might be related to how a state voted for the presidential election. So the idea is you're using percent high school graduates, percent who are heavy drinkers of alcohol, percent who are obese. The outcome Y is a percent of people who voted for Barack Obama. And the idea is that this outcome, suppose it's based on polling data. So suppose you just aggregated a bunch of polling data across these different states, because the election hasn't happened yet. And without additional information, this outcome variable, it's your best guess for who voted for Barack Obama. So this is the results from a multiple regression analysis using these different variables as inputs, right? Where the outcome is the expected percentage for voting for Obama. And so we can see that our regression model has an intercept and these three different partial regression coefficients. Now what's interesting here is that you can see that in terms of statistical significance, we find that heavy drinkers, the percent of heavy drinkers and the percent obese are statistically significant. So this model suggests that states with a higher percentage of heavy drinkers tended to vote for Obama, controlling for the other variables in the model. In a similar way, you might say, well, obesity, the higher percent of obese people in a different state, right, the lower percentage of people who you'd expect to vote for Barack Obama, controlling for the other variables in the model. High school, it's not a statistically significant predictor, treating these values, this data set, as a random sample from some population. And so we have this model, right? We might consider using this model for prediction, okay? Let's consider this model for prediction for Massachusetts. So you might say, well, what is the predicted Obama vote percentage for a state that has roughly 86.9% of high school graduates? Right? So roughly 87% of the people in Massachusetts in 2008 graduated from high school. About 6% are heavy drinkers, according to epidemiological surveys. About 21% are obese. So using this information about Massachusetts, right, we're going to try to predict whether Obama will win Massachusetts in November 2008. Okay? So we can find this using our equation from the multiple regression results. We just plug in the values for Massachusetts. Right? We have an intercept, and then we have these different partial regression coefficients, and plugging in 86.9, 6.3, and 20.7, we get an expected percentage for Massachusetts based on our simple or multiple linear regression model. We find our model predicts that 61.42% of people in Massachusetts will vote for Barack Obama in November 2008. Okay. This is our prediction for the future. Now you might see what actually happened. What actually did happen in November of 2008? Well, you can see it's pretty close. Okay, Obama did win Massachusetts, and he did win the majority of the votes. The important part here is with statistics, you can do a lot of stuff. In fact, you can predict the future. What we just did was actually made famous by the statistician Nate Silver. In 2008, he used analyses like these, including basic linear regression models, including this multiple linear regression model, and he was able to predict that Barack Obama would win the 2008 presidential election, and he predicted it across these different states. Sometimes this is called predictive analytics, but this is something that you now have in your toolbox. You can predict voting patterns. But not only that, multiple linear regression models are used to predict lots of things about the future. They're used to predict what product you will buy. They're used to predict what your credit score will be. So multiple linear regression is a very powerful technique. To conclude about multiple linear regression, it simply entails including additional inputs or predictors on the right-hand side of the equation. That's it. The coefficients are interpreted in a slightly different way. In particular, with multiple linear regression, we say that the value of a particular slope gives the expected change in the outcome for a 1 unit increase in the input, holding constant or controlling for all other variables or inputs in the model. The intercept gives the expected outcome when all the inputs are set to 0. And finally, with multiple linear regression, the idea is with the instance with 2 variables, you're looking at a plane fit through a 3D scatter plot. In the more general case, you're looking at a hyperplane fit through a n-dimensional, n+1 dimensional scatter plot of data. With that, we conclude our discussion of multiple linear regression.